Today we're going to talk about exponential functions. We'll start with the definition of an exponential function. The exponential function f is written f of x equals a to the x, where a is called the base and x, what the variable is in the exponent. That's why it's called an exponential function. Now we have some restrictions on a. A has to be a positive number not equal to 1. The reason it has to be positive is because if you take a negative number to an even power, you get a positive. But if you take a negative number to an odd power, you get a negative. But not only that, if you take something like negative 1 to the 1/2 power, remember taking something to the 1/2 power means you're taking the square root, and the square root of negative 1 is not a real number. So that's why a has to be positive. And the reason a can't be equal to 1 is because 1 to any power is 1, is itself, and so that's not actually an exponential function, that's the constant function y equals 1, which forms a horizontal line. So let's look at some examples of what is an exponential function. F of x equals 3 to the x is an exponential function. You can have the base be fractions. S of t equals 2/5 to the t is an exponential function. And you can actually have an algebraic expression as the exponent, like g of x equals 6 raised to the 4 minus 3x. Now when it comes to evaluating a function, you have to assume that the exponent is in parentheses. Even though there aren't parentheses there, they are assumed to be there, which means you need to simplify the exponent first before taking the base to that power. For example, if our function f of x was 4 to the 3 raised to the 3x minus 1 power, and we wanted to evaluate f at 1, just like any other function, we're going to replace the input with 1. So we'll replace x with 1, and we have 4 raised to the 3 times 1 minus 1. So we need to treat that exponent like it's in parentheses, so we need to simplify that first, following the order of operations up there. The 3 times 1 gives us 3, 3 minus 1 is 2, and we're left with 4 squared, which is 16. Now when we're working with exponential functions, we do a lot with the properties of exponents, so if you need to be refreshed on the properties of exponents, please go back to the videos and your notes from 0.3 and 0.4. So let's take a look at the exponential function 3 to the x. Let's see what an exponential function looks like. We'll go back to our old school method of graphing, and we'll pick x values, plug them into the function 3 to the x, and get our y values and graph our ordered pairs. So I made a table of values. I chose x equals 1, 3 to the 1 is 3. X equals 2, 3 squared is 9. Now I could plug in 3, but 3 to the third is 27, and that's a pretty large number, so I'm going to go smaller. Plug in 0, 3 to the 0 is 1. Plug in negative 1. Remember how we work with negative exponents. You cannot take 3 and multiply it to itself negative 1 time, so you're going to have to get rid of your negative exponent by moving it to the opposite side of the fraction bar. So this 3 to the negative 1 becomes 1 over 3 to the positive 1, or 1/3. Let's do another one, negative 2. 3 to the negative 2, to get rid of that negative exponent, we move it to the bottom of the fraction, and we get 1 over 3 squared, which is 1/9. So now we have the order pair 1, 3, 2, 9, 0, 1, negative 1, 1/3, and negative 2, 1/9. So when we graph those ordered pairs, and we'll connect them with a nice smooth curve, this is the shape of an exponential function. An exponential function gets really big really fast in one direction, and really small really fast in another direction. Now this function is getting really close to the x-axis, but it's not going to cross it. You can't take a positive number and raise it to any power in the world to get 0. So we actually won't end up crossing the x-axis here. Now we have another irrational number. An irrational number is a number that cannot be written as a fraction, integer over integer. The most common irrational number you've dealt with so far in your math career has probably been pi, which is approximately 3.14159. Now this new irrational number is e. It's about 2.71828, and that's called the natural base. So the function e to the x is actually called the natural exponential function. E is used a lot in finance and in biology and in a bunch of other things with exponential functions. If you ever take a biology class and you deal with exponential growth and decay, you may have e in there, the natural base. When we start talking about compounding interest and things like that, we'll deal with e as well. So a quick example of using e. This is a biology example. The population y of a bacteria culture is multiplied by y equals 925 over 1 plus e raised to the negative 0.3t, where t has been the number of days. Let's find the amount of bacteria after 1 week. Remember, t is the number of days, so we need to figure out how many days are in 1 week, which is 7. So that means we're going to plug in 7. So when we do, we take 925 divided by 1 plus e to the negative 0.3 times 7. Now, order of operations are very important here. Remember, when you're dealing with fractions, you always assume that your numerator is in parentheses and your denominator is in parentheses. And when dealing with exponential functions, you always assume that the exponent is in parentheses. So when you enter this into your calculator, you need to make sure that you put the entire denominator in parentheses. And inside those parentheses, when you're putting the power of e in, you need to put that in parentheses as well. So I want you to take a minute and try that on your calculator and make sure that you do get 824.085. Okay, that's it for exponential functions. We'll do some examples next time I see you.